Recording. There we go. Okay, we're recording. We are on lesson 5-4, congruent triangles. And in Braille, it starts on page E203. E203. And the usual suspects know they're being recorded. All right. So this little section, it goes pretty quickly. It sets us up for the next couple sections of learning some really important and famous congruency acronyms. Side, 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 angle, side, angle. We make fun of them, but they're super important. They make common sense when we think about them, but again, in geometry, we make sure we state what we have observed so that we can prove and go on to other things. So there's a paragraph of information on this page, and it discusses that it brings up that we can translate, rotate, and reflect a triangle onto another triangle so that all the vertices correspond. So you just learned that in the previous section. We learned how one vertex like A would correspond to the image of another vertex that might be D or whatever letter it is. And so those triangles then are congruent triangles also. If you take a pre-image and make an image of it, it's still the same triangle, so it's congruent. So the parts of the congruent triangles that match up, they're called corresponding parts. So we have a tactile on this page and then a tactile on the next page that we have to compare. But you just have a triangle here on this page. It's a very nice, large, laid out triangle. Whoever did these tactiles, whenever they made the large ones, they knew what they were doing. So we have the top vertex is A, and it has one tick arc in it. The bottom right vertex is B, and it has two tick arcs, the interior of the triangle. And the bottom left vertex is C, and it has three tick arcs. And then the base of our triangle CB has one tick mark. The side CB, that's the base of it in this one. The left side AC or CA has two tick marks. And the right side AB or BA has three tick marks. Okay? Got them? So if you turn the page, they have
What does that mean?
tick arcing, you'll see. So turn the page, and what they're showing is that the triangle ABC. Okay, Stormy, we'll see you tomorrow.
Bye.
Check your email.
Is there any homework?
No homework. We'll just go over it. Just check your email and watch the rest of the video.
Okay.
Okay. All right. And then if you turn the page, there's another triangle, and it's just showing that this triangle FDE is congruent to the first one, even though it doesn't look like it in tactile form because they get a really big triangle on the previous page and then the smaller triangle. They're just doing this for representation. So you have F as the top vertex, D as the bottom right, and E as the bottom left. And we have one tick arc going through F, two tick arcs going through D, and three tick arcs going through E. So the one tick arc of F matches the one tick arc of A. It's showing that A and F are congruent. The two tick arcs at vertex D match the two tick arcs of vertex B. Those are congruent. And the three tick arcs of E match the three tick arcs of C, of the previous triangle. So that's congruent. So it's just showing congruency between the two triangles in graphical form. Just getting used to looking for those tick arcs. Then the tick marks on your sides, so ED or DE is congruent to CB or BC on the first triangle because they each have one tick arc. And then side EF or FE is congruent to side CA or AC on the first triangle. And then side FD or DF has three tick marks, and it's congruent to AB or BA on the first triangle. Right? So it's just showing that in the figure, it states that triangle ABC, so in the figure, up at the top of your page, in the figure, triangle ABC is congruent. Congruency in Braille is .5, .1, 5, or .4, excuse me, .156, and then an equal sign. That's congruency. In print, it's an equal sign with a tilde over the tilde. I can never say that right. A little wiggly over the top of the equals. So that .4156 is the little wiggly over the equal, all right, in Braille. And so that's just saying congruency, means they're the same. As in mapping, the order of the vertices indicate the corresponding parts. So you gotta keep them in order. Notice that I say side AB is congruent to side FD. Notice you say if A is congruent to F, we got to say them in the same order. Okay, AB to FD. All right, and so they give all the symbols down in the bottom. They show congruent angles. Angle A is congruent to angle F. You got your ED OW indicator for angle A, and then that congruency symbol, and then angle F, and then angle B is congruent to angle D, and angle C is congruent to angle E. So that's really good practice, right? And then for congruent sides, it says down at the very bottom, AB is congruent to, and so it uses the overhead indicator. It says AB, .5 AB, and then it has, what's that, GHWHER? Yep, that's an overhead line. And then is congruent to FD, line segment or side FD. And BC, or line segment BC, is congruent to line segment DE, and line segment AC is congruent to line segment FE. All right? So a whole bunch of different, the congruent symbol, and then a reminder of what the overhead over indicator line, and which means line segment. All right? So turn your page. It just says these relationships help define congruent triangles. All right? So then we have a page break, and we have a very important definition that gets, it's famous for being abbreviated and using the acronym CPCTC. CPCTC, definition of congruent triangles. And it's a biconditional definition, which means it goes we go both ways with it. It says if the corresponding parts of two triangles are congruent, the two triangles are congruent. If the two triangles are congruent, then the corresponding parts of the two triangles are congruent. It's just saying it front and back. It's very obvious. But remember, again, in Euclidean geometry, we got to state what we mean and make sure so we can use it later to prove other things. And so CPCTC is an abbreviation for corresponding parts of congruent triangles are congruent. So instead of always writing out corresponding parts of congruent triangles are congruent, we'll just write out CPCTC in our proof writing. And that's a very common, understood little proof writing abbreviation. CPCTC, corresponding parts of congruent triangles are congruent. All right, so we'll get used to saying that. So
it's kind of a tongue twister.
It is. Turn the page, and we have example 1. It's going to give us some givens. Sometimes they tell us in writing what's happening. And it says, if triangle PQR is congruent to triangle MLN, name the congruent angles and sides, and then draw the triangles using arcs and slash marks to show the congruent angles and sides. So they have these two triangles laid out in the middle of your page. They have PQR. P is the top right, Q is the bottom right, and R is the bottom left. And then immediately next to it, it looks like a reflection. They flipped it over. Doesn't it look like a reflection? Yeah. And they have M, L, N. Now pay attention to how they wrote it. They wrote it triangle PQR is congruent to MLN. So we can match up just based on the writing. The first letter is P on the first triangle. The first letter on the second triangle is M. So angle P is going to correspond with angle M, isn't it? Yeah. And then the second letter on PQR is Q.
And
the second letter on triangle MLN is L, so we know Q corresponds with L.
Yep.
And then the final letter on PQR is R, so we know R corresponds with the final letter on MLN, which is N. So you can dissect your triangle and your corresponding and congruent angles just based on how it's written. You don't necessarily need a drawing, but it's nice to have a drawing to match them up. So P is congruent to M, Q is congruent to L, and R is congruent to N. All right? And then you can match up their sides. So PQ to the first two letters, ML. LN to the second two letters, QR. And then the outside letters, PR, are congruent to the outside letters, MN. See how you can do that? Yeah. So you can do it based on just the code language. You don't necessarily need a drawing, but you can also do it based on your drawing. And you can see that PR corresponds with MN. It's this reflection, right? So then the next drawing over, the next page over, they detail all of that. They say since P corresponds to M and Q corresponds to L, they detail all the sides. And then they have two drawings down towards the lower half of the page where they take those two triangles again and then they put the tick arcs in it and the tick marks to show the congruency in a graphic. So we have PQR, triangle PQR on the left, triangle MLN, and here's a case where they put the letters out of order. Remember I warned you yesterday they would do that? Okay, so P is to M, so it has one tick arc through it. Q corresponds with L, so that it has two little tick arcs at Q and two little tick arcs at L. And then R is congruent to N or corresponds with N, so there's three little tick arcs, and they're kind of not easy to make out. You got to finesse it. Then the sides, so PQ has one tick mark, and it's congruent and corresponds with ML. Notice I said them in order of their congruency. And then QR corresponds with LN, and it has two tick marks to show that congruency. And then the PR, the long side, corresponds with MN, and it has three little tick marks through each one of those to show the congruency. Right, so they use these tick arcs and tick marks to show congruency. And that's what the entire section is about, is just showing this congruency and practicing it, and then applying it with knowledge that they're congruent, and then how can we figure out the size of the angle or the measure of the angle or the length of the sides. All right, so tomorrow during class we'll start right out with practicing reading some of the drawings and then finding missing measurements of angles or sides, and then we'll move on to the next section. All right? Sound good? Bell's going to ring any minute. There it is, right there.
You mean any second?
Have a good day.
JJ?
Yes.